Thanks for the nice intro, Nishi. This is not a basketball. This is a basketball coach. This thing is called the Wilson 9450. And it's actually, I got a picture of it here, it's actually got a bunch of sensors inside it. So the way this works, anybody know why it's called 9450? Bunch of non-basketball. Say again? Basketball court's 94 feet by 50 feet. So the way this thing works is you just play your game the normal way. You go out, you dribble, you shoot, whatever, and this thing measures everything you do. It connects back to your phone via Bluetooth, gives you all these heads-up displays, and analyzes your game. It's incredible. It's a passive sensor that measures your game. And really, I found a very powerful, very compelling way of doing this kind of coaching. So this is my chart for my shot. And you can see 9450's got a model of what good basketball is supposed to look like. And it says your shot's supposed to be between 42 and 48 degrees of arc, which makes sense. And it turns out I'm shooting flat. Like you can actually see that I got a couple in the range, but a bunch of them are flat. Now I've been playing basketball 30 years and I didn't know this. It's not the kind of thing where your buddy's like, yo man, you're shooting flat. Just, it doesn't come up in the game that way. So this actually taught me something, and I've been playing with it for a few weeks now, and it's interesting. And I thought, this is really the way application security should be, right? We don't have the resources to give every single person, every single developer out there a coach, to look over their shoulder and watch how they're playing. But we could put sensors in place that watch how they're coding and how their application's working and alert them immediately. And there's some cool tools out there like Brakeman for Rails that starts to get to this model, right? Where you're coding, it flags a problem and notifies you immediately. But I want you to think about this model a little bit and go beyond just the tool, right? Brakeman is a cool tool, but in this talk I'm going to talk about what I call continuous application security, which is the whole process built around the idea of sensors and notifying people immediately when these mistakes crop up. So in order to do it, you got to have a model of what good basketball looks like, right? That's how this works. You got a model of good basketball, you got sensors out there that are measuring, and then you get analytics against the model. That's a powerful feedback loop, right? And that's really what we need to be creating in our application security programs. That's how we get the organizations off the ground and get these AppSec programs really moving at DevOps speed and at portfolio scale. So I've done a couple of talks on this topic over the last year. This is the first one there is application security at DevOps speed, portfolio scale. I did that last year at AppSec USA. It talks about building great application security sensors. So changing from the idea of having these tools that you run once at the end of the software development lifecycle to a model where you've got sensors that are continuously deployed and continuously gathering data. That's the first thing. Then I talked, about 6 months ago, I did a talk called Building an Application Security Sensor Network. This is some more of a practical talk where I talked about how do you manage a whole army of sensors that are out there instrumenting your software development organization. And I built some infrastructure using Puppet and rsync and custom dashboards and put something kind of nice together for this. I think that's powerful, and I'll expand on that a little bit today. But I wanted to zoom back and look at how we're doing application security for the most part. And this is sort of the model that's enshrined in the maturity models or the big scale kind of AppSec programs. And I think we're doing it wrong. You look at these programs, you see a whole bunch of applications being developed, and they're software development projects. They're moving fast. You got a lot of them, but we've got a centralized AppSec team that forms a natural bottleneck for these projects, right? All your software projects have to go through this bottleneck. Anybody experience this problem where you got to get the experts and it slows down your development process. Everyone gets irritated, and it ends up really not working very well. If you think about the kind of coverage that we should be getting, the kind of output that we should be producing, these programs are producing really minimal assurance. What do you get? You get a report with a few vulnerabilities in it, right? That's not assurance. That's not good enough. We're not producing confidence that this thing is actually secure enough to go into production. We're getting pretty minimal coverage. And by coverage, I mean both in terms of the application portfolio, like how much of it we can really cover, and how much of the vulnerability space we can really cover. These programs are under tremendous pressure to go faster. You know, if you've got 1,000 applications and your application security team is currently doing 100 a year, you're under massive pressure to cut down the scope of your reviews. Got to do more of them every day. And so we're not getting good coverage over the vulnerability space. So we're not getting very good assurance. And the last thing is we're terrible process fit. And you know, I'm as guilty of this as anybody. I've been doing manual code review and manual pen testing for 15 years. And you know, I think I'm pretty good at it, but I'm slow, right? I make a natural bottleneck. And so if I'm involved in the process, like directly involved in the process, something's wrong. You know, we're not doing it right. And so the process fit around the way we do application security is terrible. We're pissing everybody off. And I think I've heard a bunch of talks already today that have acknowledged this. Like we got to do more to be good at fitting into the process. And these programs are very expensive, which I think is another thing we can work on. So let's back up a little bit and look at the situation that we're in. So Verizon DBIR came out, 36% of the breaches were due to application security problems. You don't hear about it as much as you hear about other things like DDoS and skimmer attacks and point-of-sale attacks and so on. But application security is by far the biggest category of breaches. Yet, when you look at the spending, I think this is really interesting. Is some of the analyst firms have sort of racked up the spending in the security space. Only 1.7% of the spending is on application security. That seem out of whack to anybody? I think that's nuts, right? Anybody think of a reason why the spending might be this way? Say again?
Publicity, espionage.
Oh, yeah, some of these things do get bigger publicity, for sure. I think AppSec is a little more difficult to describe. But I actually think it's kind of our fault. Like, we've made it very difficult to spend money in application security because you can't just go buy one product. You got 24 vendors out there that are competing for those dollars and consulting. So it's tricky, but there's something very wrong with this picture. So I want to think about it a little differently. I want to think about looking at the software development organization as a factory. And if you've read Gene Kim's book, Phoenix Project, you'll understand where some of this is coming from. But if you think about the software factory, its job is to produce, take business needs in and produce software out the other end. And we want that software to have certain attributes, right? We want it to be secure code that's coming out. And the traditional way that we've dealt with this is we put up these roadblocks in the way. We say we're going to check at various phases of this process to verify that everything is on track. The problem with that is it just slows everything down, irritates everybody, and it doesn't end up producing the results we want. I like that expression that says, the internet sees censorship as damage and routes around it. Well, I think for security, development organizations see delays as damage and they route around them, right? So we're getting marginalized because we're slowing the process down. And the solution, obviously, is to do our job faster. And really, that's the focus of this talk. Fast really is everything in application security. If you want to make a difference, you've got to be in real time. So we'll talk about how you get there. I took a look at some thinking about real factories and how they've dealt with this problem. And it's interesting. I think a lot of industries get to this point where their ability to produce product very quickly exceeds the ability to do quality work on those products, right? So you can think of the auto industry in the 70s. We started producing lots of cars really fast, but the quality was terrible, and Ralph Nader wrote about it, and unsafe at any speed, lots of those kinds of examples. What's happened in the industrial manufacturing area is that modern factories are massively instrumented. So these are just some of the sensors that you can get. There's cameras and microphones and vibration sensors and moisture sensors and all kinds of different things that you might want to know what's going on in your factory. They instrument everything. And then those factories communicate. These are just a bunch of the adapters that you might need if you want to instrument, actually stand up a real sensor network that all feeds back. So you get all these signals from all these sensors, and you bring them together in a programmable logic controller like this one. This is the model. Like if this is the sensor in the basketball or in your industrial welding machine or whatever it is, all those signals come together in the programmable logic controller, and there's a model in there that says what good factory operation is supposed to look like. This is where the analytics happen, right? So we're starting to put together a picture here, right? It's sensors, model, and then these analytic dashboards, and then you can pull all that together and make these great dashboards to make sure that you understand problems before they're a problem, right? This is, I believe, how we need to do software if we want to get in front of application security, is this model, that feedback loop where we have sensors compared against a model, and then we produce analytic dashboards against them. So I'll talk a little bit about some things that are going on. So one thing that I see people talking about a lot is taking a bunch of crappy sensors for AppSec, really noisy sensors. And they say, well, you know what let's do? Let's cobble together a few static tools and a few dynamic tools, and we'll smash the results together, and we'll correlate them, and we'll get good output. And I don't think it's possible. I think we really have to focus on super high quality sensors if we want to make this process work. I think what you get if you do this is you get a weird subset of the security data that you really want. The things that, the overlap between SAST and DAST is not that great. You end up finding a few problems that are not well correlated. And you miss anything that can't be discovered by both technologies, which is a significant portion of the security data that you want to gather. So I'm not crazy about this approach. What we need is really better sensors. And I'm thrilled to announce a free tool that we've just released. This is the first free IAST tool available. It's called Contrast for Eclipse, and it works differently than SAST and DAST. This tool, and this is, by the way, in case anyone's concerned about me talking about a product here at OS, I'm very sensitive to that. This product is totally free, very much like Burp is a free tool that has a pro version. So I got this approved by the OS board, and this tool is very powerful. It uses instrumentation in a new way to find security vulnerabilities. And you can download it and install it. It's in the Eclipse Marketplace. It's called Contrast for Eclipse, and you can just grab it. It takes 30 seconds to install and start using. I'm going to show you how it works. So I'm going to clear this out. When you first bring it up, it comes up like this. And in order to start it, you just, instead of starting your application the way you normally would, you just right-click on this. And instead of hitting Start, you hit Start with Contrast and fire up the application. So I've done this. I've got WebGoat running here with the instrumentation turned on. And all you have to do is just use the application the normal way. You don't have to hack it. You don't have to know anything about security. So I'll just put LASCON rocks here. And Contrast automatically analyzes that request in real time and reports the vulnerability to the plugin. Okay? So here's the SQL injection vulnerability in this page. And you can double click on it and go right to the line of code. You've got a little risk description here. You've got the full evidence. So this is each of the lines of code involved with this vulnerability. So I could go up to the top here and say, oh, this is the line of code where that parameter gets read in. You can see here it says LASCON rocks. And we watch that data flow through the application into the SQL query, and you can see that the lines of code where that query gets built, and then the line of code where that query gets executed. So we've really got a very rich set of data related to this vulnerability. We've got the full stack trace if you want to, for any of these events, if you want to dig into that. And we got the full HTTP request. So if you're used to static tools, you're used to getting sort of that line of code information. You don't get the runtime data flow, but you're used to that line of code information. If you're used to dynamic tools, you're used to getting vulnerabilities that look like this a little bit. But you need them both together. If you're a developer and you want to fix this problem, you not only need the line of code, but you need a test case in order to verify it and test that you actually fixed it right. Because Contrast runs inside the running application, we have access to all of that. So I wanted to give you and just show you how it works, and now I want to tell you a little bit about how it works internally. So what Contrast does is we attach to the running application server and instrument the code as it loads. So we're inserting, we're using instrumentation to hook certain methods, interesting methods to us, like request a get parameter and SQL.execute statement. All those calls, we instrument them, and then as you use the application, Contrast passively observes what's going on, doesn't affect the way the application runs, and reports the vulnerabilities out. So that was a lot. I want to pause here and just take any questions. Anybody got questions about IS? Yeah, right here.
Which languages it's going to work on?
So the free, this is just for Eclipse. I mean, if you want to stop by and see the commercial tool, that's another thing. But this is just for Java and Eclipse. And you can actually run it with other IDEs if you want. There's a way of running it outside the container and getting the feedback the same way. But really just Java web apps and web services. Any other questions about IaaS or how this is actually doing what it's doing?
We don't have one for .NET.
Not a free version. There's the commercial tool, but no, I don't want to talk about that here, okay? So what I'd like to do is show you just how real-time this is and why it makes a difference that it's so fast. I've got a Selenium test suite set up here for WebGoat, and I took 3 minutes to record this. Like you just hit the record button and just browse through the application once. You don't have to put in any attacks or anything. I'll just start this, and then you can watch the vulnerabilities will just, so this is just executing WebGoat, at relatively high speed. And you can just see the vulnerabilities start pouring in because Contrast is analyzing all of that part of the application that gets exercised in real time. Now this makes a huge difference if you're a developer and you're working on your application, you just test locally, you run your test cases, you run your Selenium test suite, or you just use it manually, and you get instant feedback about the code that you're writing so you can fix it right then when it's cheap. You don't have to wait days or weeks as you upload your code or schedule a scan and get a PDF report and filter out all the false positives and finally get the vulnerability and not have all the information you need to fix it. Contrast works in real time. I started work on this about 5 years ago, and I stepped down as the chair of OWASP to work on this because I thought this was such a promising technology. And back then, I was really only interested in accuracy because I thought that was what everyone really cared about. And this technology is way more accurate than other vulnerability detection because we've just got more information, right? We've got information about not only the code and the HTTP request, but we also see the runtime data flow. We see all the libraries and frameworks in the application. We see all the configuration files, even all the back-end connections. And so we can use all that information to decide whether something's a vulnerability or not. So we really only report the real stuff here. But I was really only worried about accuracy. What I found is that the real-time nature of this is actually much more important. If you want developers, if you want a real software process to do application security for itself, being real-time is absolutely what you need. If you think about the software development process, doing security the way we do it now is very burdensome. I was going to say expensive, but burdensome is probably a better term because it causes a lot of effort. You have to stop and do it, which means that people are naturally inclined to not do that until the last possible minute, right? You don't want to do it over and over because it's burdensome every time you do it. So people end up pushing it to the end of the life cycle and only doing one big test at the end. But if you can lower the burden of doing application security to almost zero, then you can do it continuously throughout the application development process. You can do it in dev, you can do it in CI, you can do it in staging and test. And it's actually really powerful. If you think about your process, wouldn't it be cool if you could see, hey, look, here's all the vulnerabilities that we saw in dev and fixed, and then compare what we see at the CI server when we run our test suite. Oh, look, only a few vulnerabilities got through to here. And then you can compare that to what you see in a staging environment. And hopefully you're down to zero or very few vulnerabilities. And if you do get one in staging, you should think like, hey, wait a minute, how did that happen? Who ignored some step here in order to get us to this point? So you can really track vulnerability production across your software development lifecycle much better if you can do things in real time.
So I am guessing that probably the number of false states is extremely low on this because it's running.
It is low, so contrast really only reports things that actually happen within the web application. So when we see a SQL injection, it's because we actually tracked that piece of data through the application, down into the libraries and frameworks, and back into the code, and down into the frameworks, and eventually we see it end up in a SQL query that goes to the database without going through any escaping or protection.
Does it also look into the libraries?
It does. So this analyzes the libraries. If you look at the bottom of the list here, you can see we analyze just the libraries that are available in the actual running application. So we watch which libraries get loaded, and we analyze them. We actually check them against our database, and we see, which known vulnerabilities are present in those libraries, which is OWASP A9, if you're interested. So, I think it's an important thing to do. Yeah.
Can developers add tasks to it, or does it just run the tests as part of their own?
It is possible to extend the rule set. It's not really exposed in this Eclipse plugin. Really what we're trying to do with this is, we're trying to get people to be more aware of application security and trying to get them focused on, some of the problems that are really important. So this covers most of the OWASP top 10 really well, and we're trying to get that out there to sort of raise the bar. I wrote the OWASP top 10 in 2002, and it's still got the same stuff in it, which is massively frustrating to me. It means that we've failed and OWASP has failed to change the way software works. And that hurts me. So we're releasing this tool to try to raise the bar. If you have this tool and you release software with a SQL injection vulnerability in it, I really think you're being careless. Because this is giving you really good information about whether it's there or not. Any other questions? Okay. So let's look at what this means for an application security program. So you've all heard of continuous integration, continuous delivery. I think of continuous application security as being the way that we want to practice application security. I want it to always be up to date. I don't want to have this thing where we periodically run a scan and make a big shift. And if you think about, waterfall methodology is really an exercise in doing a whole bunch of development and then checking hey, where are we against that model that we may or may not have specified very well, making a massive correction, and then continuing on and doing that again. Continuous is really much smoother. You make almost constant adjustments against the model. And somebody described it as when you're riding a bike. When you first start riding a bike, you make these big overcorrections all the time. Continuous is more like when you're an expert bike rider and you just make little corrections to stay against your model, much smoother and better. So continuous is, I think, a really important aspect of application security. And I did a lot of work in this over the last year or so. Basically, what I tried to do was look at all the different application security practices that are out there, maturity models, and going back to the Orange Book and common criteria and so on, ISSE CMM, all those things. And I threw away everything that doesn't contribute to assurance, because there's a lot of stuff we do that there's no real direct line to anything that matters. Anything that doesn't scale, anything that's not real time, anything that's irritating, frankly, because I think those destroy application security programs, or anything that's tied to a particular phase of the software development lifecycle, threw it away. And I said, what's left over? And I tried to mix in principles of Agile and DevOps and come up with something different. So I put together this thing called a Continuous Application Security Handbook. And it breaks down this idea of doing continuous application security into 8 practices. And the idea really is tied to the idea of using sensors like Mr. 9450 here, Mr. Wilson, and using sensors to gather the data, comparing against a model throughout application development, and really focusing on whether the goal has been achieved. Like, did you actually produce something that shows that your application is secure enough to go into production? And in particular, I wanted to avoid the involvement of experts or gates in the software development process for security anywhere. I think if we can eliminate those, then we've done a massive improvement towards continuous. So I don't have time to go through all the practices here, but I want to focus on the core three. These three practices, I think, create the feedback loop that we really want. So the first thing is instrument everything. Second, we'll talk about making security visible. And then the third thing is taking control of security. And I sort of see them evolving that way. So the first thing that I want you to do is instrument everything. This is not just instrumenting with a tool like Contrast for Eclipse. That instruments one little piece of this process during development. But you can instrument lots of parts of your process to gather data that you need to figure out whether security is going right. So the first thing is put those instrumentations out there. And I think it's interesting, Alex Stamos over at Yahoo, he's asking for this. He says, vendors trying to sell us pizza boxes, that's not what we're looking for. We're looking for software sensors with centralized intelligence. They're getting it. So this is the direction that I think people are actually moving. I like what Gene Kim said about this. He said, if you have code that's important enough to deploy, you have code that's important enough to instrument. And I truly believe that instrumentation is the future of software. I think in 5 to 10 years, all of our software is going to be instrumented all the time to gather the data that people need in order to see that it's working correctly. So imagine you've got these sensors out there. Maybe you're using Contrast for Eclipse. You've wrapped some other tools, like Zap is a really great tool to put out there as a sensor. You can run Zap in a passive mode in your test environment. Just let your testers test through Zap, and it'll gather a ton of data. You can pull the data out with a REST API and make security visible. So this is a really important thing culturally. This is where you compare that data against a model and produce great dashboards that show people how on track they are or where you're veering off from the model. This allows people to correct very quickly. And it can't just be for the security team. This has to be exposed to development, has to be exposed to audit. There's probably C-level folks that need insight into this so that they can be sure that application security is on track. Look for a couple dashboards out there. Yelp has a really cool one. This is their CSP dashboard. So y'all familiar with content security policy? It's an interesting way of stopping XSS in the browser. And one of the features of CSP is that it reports back to a central server if there's problems. And so Yelp is getting thousands of reports a minute back. Now, they can't deal with each of those things individually because it's just too much, but they can gather it together and create great dashboards that show them, look, here's what's going on with CSP across all the different environments that are using Yelp. So I think this is a really powerful way to let development know that security is on track. Here's a dashboard from Etsy. Zane Lackey posted this. He said, you got to surface security information for everyone, not just the security team. And you can see, I don't know the details of all these different dashboards, but you can see they're monitoring a whole bunch of different things within their organization to make sure that security stays on track. This is the one that I threw together for my talk. We use this internally at AppSec to monitor a number of different applications that we run. And it's powerful too. It allows you to slice and dice the data in a bunch of different ways. So I encourage you to just start. It's actually not very difficult to deploy some of these sensors, pull the data together, and get it going in a real-time dashboard. You don't have to invest hundreds of thousands of dollars in order to get these things started. You can start this today. In the first talk I talked about application security at DevOps speed and portfolio scale, I talked about building some very simple sensors, things that monitor security headers and things that do other simple security checks, gather the data together, create a dashboard. And what's really cool is I've done this in a number of organizations now, and you don't have to start with a deluxe dashboard. Start with something very simple, but it catches on like wildfire. You'll change the culture by just deploying some sensors, getting a dashboard, and starting that feedback loop. Now, this raises the question of what do we want to gather? Like, what sensors should we have out there That's actually the million-dollar question for this, is how do you can't monitor everything, so what should you be monitoring? And I encourage you to take control of security. What I mean by that is many organizations have their security requirements all over the place. So they've got some security policies that are really vague. That's part of this. They have some security guidance and security requirement documents. Maybe they got some security test cases. They're not connected together. They're all over the place. And the problem is nobody ever has a sense of what is actually important for security to the organization. In fact, some organizations don't have any of that stuff. They just rely on a tool that they're running. They say, well, for security, what are we doing? Well, we're running some scanner tool. Who's got control of security? Well, it's whoever wrote that tool, right? And just so you know, tools report the things that are easy for them to find. They don't report the things that are important to you. So it's prioritized all wrong. So what I want you to do is think about what do you currently care about? And you can look at what security controls you got out there. You can look at what tools you're using and sort of reverse engineer the security policy that you're actually trying to enforce. It's a few hours exercise to start putting this together and building up a list of what you actually care about. Then that's your model, right? That's your 9450 model. That's what you're going to be measuring against from then on. Once you have then you put the sensors in place to measure against the model, and now you've started this feedback loop, right? You've got sensors, you've got the analytics that you're measuring against the model, and the process is, new threat comes out, you improve the model, roll out a sensor, and now it's part of your dashboard. That's the feedback loop that we want to start going. Once you do that, that's how you get secure. You iterate that model faster and faster until you are really improved. And it's a lot simpler than these big heavyweight maturity models that are out now. We're going to talk a little bit about how these models and sensors work. Most organizations, it looks a little bit like this. You've got a model, but it's not well defined. It's really spotty. And a bunch of the stuff that you really care about is not being tested. So I see tons of organizations where, they're testing, they care about things like access control and encryption algorithm strength and so on, but they're not testing it at all because it's not what their tool can do. It's not what their pen testers can do. And then on the other side, you deploy tools and sensors to measure things that you don't care about. That's just pure waste, right? So I've seen people that have deployed tools to test for SQL injection on applications that don't have a database. That's probably not going to work, okay? So you need to get these things in alignment. You want to have your model, and then you want to measure against the model with sensors in real time. Otherwise, you'll end up with just this, and this doesn't mean secure, right? So those are the three core practices in continuous. And you can stop by our booth. We've got a bunch of copies of this. If you want to dig into this and understand how you can really start a continuous practice. I'll run through the other 5 quickly. There's an important activity about knowing your enemy. This is monitoring sources like OWASP and FIRST and other organizations that look at threats to make sure that you're defending against the right stuff. Because you don't want to be 2 years, 3 years after something like CSRF is discovered. You don't want to finally discover it and then try and put in protections too late. I see lots of organizations do that. So who here would say that their enterprise is fully defended against XML external entity injection? Not a lot of hands up. How long have we known about that problem? That's got to be three years, something at least. Why are organizations not taking it seriously? Well, it just hasn't become part of their model, and they haven't rolled out the sensors yet. Because even a lot of pen test firms aren't testing for that yet, because it just hasn't achieved significant visibility yet. So you got to know your enemy. Implementing strong defenses is a thing that I'm really passionate about. I spent some time writing the Enterprise Security API here as a way of sort of standardizing security defenses for things like validation and output escaping and logging and encryption and so on. And when you centralize and standardize on strong defenses, it makes your model so much simpler. Because now, instead of asking 50 questions about, is your authentication implemented correctly for all these various things, you can just say, did you use the standard authentication mechanism? It's one question, one sensor that you need to deploy. So you can make things massively simpler if you use standard strong defenses. You should hack yourself, and this is part of that feedback loop, is this is where you improve. You should have an activity that you're continuously practicing that looks at both your implementation and your model and tries to find loopholes. And there are people out there that are really good at that. You should spend some time poking holes in your model and strengthening it. Then, once you do, roll out the defense and roll out the sensor to verify that defense. You should expect failure. This means that you are going to get breached eventually, and you should be ready. And there's some practices that I describe in the handbook about being ready to handle a breach and respond quickly so that it's not terrible. And then the last thing is I also think it's important to promote security culture. Now, frankly, if you do the first three things, you'll be well on your way to generating a security culture that is compatible with software development. You'll be giving developers feedback in real time, useful feedback. You won't be slowing them down. You'll be helping them out. And this really is about broader themes, doing some training, doing some awareness, raising visibility of the whole organization about security. And that's it. 8 simple activities to get a continuous application security program going. So I encourage you to think about the model here. It says right on here, it says the ball don't lie, which I think is important to think about. The sensors don't lie. They are ground truth. And I think we could use a lot more of that in application security. So thanks a lot. I'm here to meet you. Please seek me out. You can come by if you want to see more of a demo of Contrast for Eclipse. Please stop by the Contrast booth. And you can pick up a free handbook. And that's it. I'd love to take some questions. Come on, am I crazy? Yeah, go ahead.
Do they have the top 10 handbook here? The top 10?
The OWASP top 10?
Yeah.
I don't know. There might be some printed out somewhere. Somebody gave me a shirt in Boston with the OWASP top 10 printed on it. Does that count? Who thinks IASC is a good idea here? I'm just curious. Who's going to give this thing a try?
I think it's very cool.
Great. If you've used SAST or DAST in the past, then I absolutely, that's like Dr. Seuss. I think you absolutely should give IASC a try because it is different. SAST and DAST have been around for a long time and they haven't really evolved. There's not a lot to open source there. But you can add rules. I mean, it's open in the sense you can add rules and deploy new sensors on top of that IASC platform.
Yeah, how about false positives? Does it give a lot of false positives where you have to track them down?
It's really, it's significantly less false positives than a traditional SAS or DAS tool. And the reason is we only report things that actually occur within the application. So, we don't lose the thread like static tools do. So there's none of this lost syncs and lost sources and all that sort of stuff. The only kind of false positives that we do have are if we don't know about a validation method that you're using. Like if you're using not something from Apache Commons or SAPI or whatever, if you're using your own validator, then you'll see a vulnerability there, and you should say, oh, you know what, that's validated. Add the validator, and then it goes away. Right? So you have to train it to your validators and encoders a little bit. Yeah?
So how does it do with the Java frameworks?
It does really well. So this is a major advantage. Because we're inside the running application, we have, we don't need to teach our tool everything about the framework. Static tools, they don't analyze the whole app. They only analyze the custom code. So every time your code calls the framework or the framework calls your code, the static tool has to have some knowledge of how that is supposed to work, what's going to happen. Ours doesn't because, we trace the data wherever it goes through all of that code. So it's much easier for us to handle new frameworks, and we handle all the major Java frameworks and web service frameworks that are out there.
How does that work?
So for the most part, the Contrast for Eclipse tool focuses on just the OS top 10 kinds of problems. We don't do we have something in every area, but we don't do a lot for access control or authentication, because those are often custom kinds of implementations. But sort of the other 8 OS top 10 items we find really well. You can train Contrast to find custom things for your code. So underneath the IaaS agent is just a pattern matcher. It says if we see a certain pattern in the code, we either we report that as a vulnerability. You can model positive rules as well, in which case Contrast looks to see if that pattern is there to verify that it's been followed properly. I'm a big fan of positive security rules, meaning that the tool should model what the application is supposed to do, not what it's not supposed to do. Right? It's much more accurate to model positive rules, but that positive rules you have to kind of teach it a little bit. Right? You have to tell the tool, here's how we're doing access control, and then Contrast can verify it. So it's possible, but some custom rules for positive stuff. Yeah.
Talk about sensor reporting. Is this
Oh, yeah.
production ready, right? Are you linked to dev tools, or is this something?
Well, the Contrast for Eclipse is just for development. If you want to talk deploying in test environments or staging environments or production, just come by the booth and I'll tell you about that. But yeah, it's production ready. We've been working on this for a long time. We actually won a Navy contract to focus on performance of the agent. So we're really good at real-time instrumentation. Very much like the way New Relic works. I don't know if you're familiar with the tool New Relic, but it's an application performance monitoring tool. You just drop in the agent, just like you drop in this agent, and it does the same thing just for performance. This is doing that same thing for security. Yeah, so everything that happens within the JVM, this tracks. We do have the ability to track some things off JVM into the database and back. If you're using standard database APIs like Hibernate and so on, we can do that. But what we haven't done is link up applications that are composed of multiple different pieces. Like if you've got a web service or multiple web services that there's a central front-end controller, we don't connect the trace between all the pieces of the application yet. Right. All right, thank you very much. I appreciate it. Come on by and talk to me.